Today we'll be solving graph questions. Yesterday we were able to solve island perimeter, but the time complexity of that was m into n. Yeah, and the space was also m into n. So the editorial the last day we saw that editorial has a better time and space complexity, not the space complexity. So let's see what that space complexity is and try to understand what's going on exactly. So here, go through every cell on the grid. Whenever you are at a cell, uh, land cell, look for surrounding up, right, down, left cell. A land cell without any surrounding land cell will have a perimeter of 4. Subtract 1 from each surrounding and land cell. Okay, got it. So if this is equal to 1, then we have to check if r equal to 0. um, okay, if r is equal to 0, up and up, down, left, right, they have defined up is equal to 0. Okay, then up is equal to grid of r minus 1 c. Okay, let me see what's going on. So I'm here. So water, water, land, water. Oh, okay. Whatever the land is there, we are subtracting the land from the land that we have considered. Okay, got it. So if r is equal to 0, okay. So yeah, looks like got it. What's going on? Okay. So why don't we just do this? Will for every loop that we are going to go that we are going to have, then why don't we set up, down, left is equal to 0, and then just check up, or like whatever is on the top. Okay, if r is equal to 0, up is equal to 0. Okay, we are on the last one. That means, and up is equal to grid of r minus 1. But okay, if okay, got it. Mm-hmm. And if we have to go left, then we have to also check if that is c. If c is already 0, then we cannot go left. If okay, down, got it. Why they have done this edge casing? I've got it. Okay, yeah, pretty straightforward. So where m is the number of rows and n is the number of columns of the grid, since two for loop go through all the cells on the grid for a two-dimensional grid of size m into n, the algorithm would have to check m into n cells. Got it. And the space complexity is of 1. Only the result variable is updated. Yeah, true that. And let's see the second approach, what they have done here. Approach 2 has the same time and space complexity as approach 1. Even though they have the same time and space complexity, approach 2 is slightly more efficient than the approach 1. Rather than checking 4 surrounding neighbors, we only need to check 2 neighbors left and up in approach 2. Since we are traversing the grid from left to right, okay, from top to and from top to bottom, yeah. um, for each land cell we are currently at, we only need to check whether the left and up cells are land cells, with a slight modification on previous approach. As you go through each cell on the grid, treat all the land as having a perimeter of 4 and add that up to the accumulated result. If that land cell has a neighboring land cell, remove two sides, one from each land cell, which will be touching between the two cells. If you your current land cell has a up land cell, subtract 2 from accumulated result. If your current land cell has a left land cell, subtract 2 from your accumulated. Okay, let's see what they are trying to say. So we are always traveling from left to right and top to bottom, right? So that's what they are showing here. So when we encounter a land, then what they are doing is plus 4 they have added, and then again plus 4 they have added. But for this guy, they encountered a cell which is -2 from here. Okay, then again -2, as this cell is matching. Got it. But plus 4, then the top. Got it. Yeah, what's going on? Okay, I see. Yeah, but I guess if you can come up with even this solution, that would be great. And this is just like we are using extra memory here. That is the minus side of this. But yeah, this solution also works. So what we'll do is we'll go and see, check this, take this question as done. And we saw yesterday that this question, okay, I guess it's a good question to be asked. So let's star mark it and let's go verifying an alien dictionary. What's that? Looks like I haven't solved this question. So let's try to solve this question. Okay, let's time ourselves. So, verifying an alien dictionary. In an alien language, surprisingly, they also use English lowercase letters, but possibly in a different order. In different order, okay. The order of alphabet is some permutation of lowercase letters. Got it. Given a sequence of words written in the alien language, and the order of the alphabet return true if and only if the given words are sorted lexicographically in this alien language. Whoa. Okay, hello and Leetcode is given to us, and they have given us the order. Okay, order of their alphabets. So as H comes before L in this language, then the sequence is sorted. Oh, okay. Let me read that again because I didn't understand it. So in an alien language, surprisingly, they also use English lowercase letter, but possibly in different order. The order of the alphabet is some permutation of lowercase letters that is given. Okay, till this part I'm with them. Given a sequence of words written in the alien language and the order of the alphabet, return true if and only if the given words are sorted lexicographically, okay, in this alien language. Got it. If the words are sorted, okay, got it. What they are trying to say, I think I understand. So looks like words, right? So let's see. So here I can, so what L they are comparing, I'm not sure whether they are comparing Leetcodes. So given, hey Chris, thanks for following. Yeah, so we were checking that given a sequence of words written in the alien language and the order of the alphabet written true if and only if the given words are sorted lexicographically in this alien language. So let's see, as H comes before L in this language, then the sequence is sorted. Okay, let's see this one, word, world, row. As, and the answer is false, as D comes before L. Where is L? Okay, as D comes after L, yeah, in this language, then words of 0 is greater than, okay, greater than words of 1, hence the sequence is unsorted. Whoa, okay, got it. Words of 1, words of 0 is so how should we do this? And this is a easy question. So looks like word, world, row is given to me, and then in this case world is in, okay, the first letter should be small, first word should be smaller than the next one. So the first, like, I don't know if this way of thinking is right. Excuse me. So what I can do is I can okay, I can just loop through the order that is given to me and store it in the hash map, indicating their place in the alphabetic order. Like if H is coming at 1, so it will be 1, L will be 2, A will be 3, B will be 4, like that. And what we can do is for the word, and then when we are traversing this word, what we can do is we can simply calculate. No, so what I was thinking, I can just take the sum of the word, like characters here, and then compare it with this one. But you know what, like there might be, so H they can use n number of times and still it will be smaller than the Leetcode. So yeah, but yeah, so if I calculate H for 100 times, then that would be greater, and my logic is not going to work there. how do you basically compare them given the words? Hence the sequence is unsorted. So do I, like, this is what they have given me and this is what they are asking me to compare if they are sorted. Whoa, alien dictionary. Is there a hint or anything? We are 6 minutes into this question. Okay. Hello, Leetcode, and the words is given to me. Sorted lexicographically. What is that? Lexicographically. Let's see. The editing of making dictionary, the principle and practice of dictionary. Lexicographically and lexicographical order is a generalization of alphabet of the dictionaries to sequence of order symbols, or more generally. Okay. So why don't we do this? Okay. If I start comparing the words like L and D. Nope. So I think we have to find the largest one, like whatever the sequence of this word is, we have to find the largest character like in the sequence, and then we can compare it with this largest one, and if this is smaller than the largest that we have found in this one, then this sequence is okay, but that is an overkill. Like what data structure I can use? Can I use DFS? Like, and if even if I'm using DFS, how will I go about traversing this input order and words length that is given to me? Verifying an alien dictionary. Word 1 is greater than word 2. Based on what? Hence the sequence is unsorted. Apple app. So here also Apple app is there. APPLE, and this is our traditional one. So APPLE, the first three characters of app match and the second string is shorter. LE, second string is shorter, this guy. Yeah, according to lexicography rules, Apple is greater than app because L cannot be matched with anything. Okay, so are they just matching the words letter by letter, like the character by character? So H, they are comparing with L. As H comes before L in this language, then the sequence is sorted. Oh, okay. And in this word, W is equal to like this guy, O is equal to R is equal to this, and D comes after L, so that's why it's false, right? Okay. And got it. Like what's going on? I see that. Okay, so what I have to do next is and in this case app A P P L E. So till this point it was okay, but this sequence is shorter, so that's why it's returning false. So why don't we go ahead and can we do, like, this is a classic sorting problem, right? So why don't we find a mid and then, like, kind of like merge sort. We can do the merge sort here, or or that would be an overkill. Yeah, like the brute force would be of n square, or like we'll be checking this hello with all the occurrences of the words that are be given to us, and word dot length is 100. So yeah, hello would be compared with all the letter all the words, but again we have to compare also um, the h and every character in that word with all the characters in the, yeah. So the time complexity is going to be really worse in this case. All characters in words I, and the word length is 20. Okay, maximum it can be 20. So let's see what we can do. Oh, we are already 13 minutes into it. Like, let's see the editorial, and let's see if we can figure out at least by reading the overview, if we can code that out. If not, then we can just see the solution. Okay, to check if the given words are sorted, for each word we need to check if every word on its right is lexicographically larger. Likewise, for each word we would check if every word on its left is lexicographically smaller. Yeah. That said, we don't need to compare every word to all the words to its right. Instead, we can just compare each pair of adjacent words. If all pairs of adjacent words are sorted, then we can safely conclude words is sorted. Furthermore, if any pair of adjacent word is not sorted, then we know that words is not sorted. Okay, cool. Compare figure 1, compare adjacent words. So we don't have to compare all the words, but what we can, a is greater than equal to b, then we have to check the b with some other word, and so on and so further. So that makes this guy. Okay, we have to just compare two words and then keep moving forward. But when we are comparing two words, I guess yeah, but before we do that, we need to actually know the sequence of this. So I guess the hash map must be needed, like for let ch of order, and everything is unique, I believe. So what I'll do is map dot set ch. I guess I cannot, I'm not sure if how I can bring in index. So I is equal to 0, I is less than order dot length I plus plus. Oh, whoopsie. Okay, order of ch, and then I plus 1, sorry, I plus 1. Okay, so we have that, and now what we have to do is we have to basically compare two items every time, right? That's what we have to do. So basically we have to make a for loop for let I is equal to 0, I is less than um, words dot length minus 1, okay, I plus plus, and we have to compare if compare this both the guys, compare word of I words of I and words of I plus 1. Okay, we have to compare those, and if that is true, then that is okay. If not, let's put a bang operator here. If they return false, then we will return false, otherwise we will keep reversing the other pairs and then return true. Now the only question is how we can reverse. Sorry guys, I'm getting a message. Let's see. Okay. Oh, shoots. Okay. My friend's birthday is there. Okay, thank God. I didn't forget. Like I almost forgot it, but yeah. Okay. Anyways, we have a function compare, and which takes in word 1 and word 2, and we do have access to the map. Oh, I didn't define it yet. Let map is equal to new map. Okay, let me make this screen bigger. So yeah, once we have this map, what we can do is we can start okay, have a pointer at both the pointer. Let I is equal to 0 and I is and j is equal to 0, and if and while I is less than word 1 dot length and j is less than word word 2 dot length, we have to kind of keep this sorted. Like we need to compare those, and word 2 should be always greater than word 1. That is our criteria, right? So yeah, if word let's get, first of all, let ch let's call it index, let's call it index, ch index of word 1 character index. Let's get it get that first. Map dot get word 1 of I. Okay, so that's what will get us the character count of, like, the index of that particular word, and we'll get word 2 index. And if word 1 ch index, it should be all smaller, right? Word 1 index should be all smaller. So if word 1 index is greater than word 2 ch index, if they are equal, then I'm totally fine. But if they are like that, then we have to return false. Okay, else what we gotta do is else we don't care if yeah, if word 1's index is less than equal to the word 2's index, so we don't care, like we can keep moving forward. So I plus plus and j plus plus. Okay, and once we are done with that, what we can do is, yeah, so this loop is anyways going to break after either of them um, yeah, gets sorted. But I guess there is one more condition, um, like what we saw here. Let me, yeah, this apple and app, if word 1 length, I guess if it is greater than word 2 length, then we can also return false in that case. So can I do something here? If while if word, if I is less than word 1 dot length, meaning that word 2 ended, so we can just return false in that case. Yeah, or else in that if apple would be in the app's place, then that would be called sorted, so we can just return true for this, right? We only care about if the app the second word is greater than the first word. So okay, we are returning true, we are incrementing the indexes. Yeah, we are super fine here, I believe so. But yeah, let's see. So if I just run this, oh, ch is not defined. Oh, okay, sorry, my bad. I Okay, yeah, that works. Cool. So can I submit it? Is there, so word 1, okay, I guess I can submit it. Wrong answer. So 60 out of 125 I guess got solved, and then K, U, V, P and Q, we outputted false. K, U, V, P, right, and Q. Oh, so K, looks like my logic for um, like returning false was wrong somewhere. N, J, L, K, and where is the Q? So Q is over here. So U, V. Oh, okay, got it. What they are trying to say, I got it now. Less than equal to, okay, so if that is the case, then I can move forward, or else, and else if word 1 ch index is equal to word 2 ch index, then we can basically increment both of these guys, both of these pointers, and else if word of 1 ch index is, yeah, if it is less than, okay, if it is less than the less than the word 2 ch index, then I need to just increment I plus plus. Yeah, I need to just do that and keep my j pointer there itself, right? Yeah, and if I is less than, like if we are not able to further traverse, yeah, then this condition remains valid. But I guess Let's add it to the unit test, this one, and let's see if that works or it's still throwing error. Okay, yeah, now it's still throwing errors. So word1 equal to word1 ch index, if it is equal to this guy, so the first one itself is failing, so false, we are returning false. So let's see, let's break this down. What happened was we came here, like we are comparing lead code hello and lead code. H comes before L, so that is okay. We incremented I, then E comes before oh comes after L. Okay, so once we find a letter that is, once we compare the first two first letters of both the words, should we move the pointer if they are satisfying the condition? Yeah, looks like that. If it is, so this totally changes this equation. If word1 ch index is less than equal to word2 index, then I will increment both the pointers, right? Else if word1 ch index yeah, but this KUVP, so the Q is here, K is smaller than this, so I guess we are incrementing the counter. Okay, I guess I should probably see the editorial. It's been 28 minutes already, so let's do that. Compare adjacent words. Following the above overview, we want to compare each pair of adjacent words to see if they are sorted lexicographically. This can be achieved by naive for loop iterating over the input array. We can store the letter order relation of letter with its ranking in order, so that we can easily access the order of letters when we compare them. The remaining piece of the puzzle is how to compare two words lexicographically. Yeah, this is not difficult, but there are few edge cases that we must consider. Yeah, that's true. To compare two adjacent words, word I plus 1, we want to find the first letter that is different. Yeah, if words of I has the lexicographically smaller letter, then we can exit from the iteration. Yeah, we know word of I and are in the if word of I has the lexicographically smaller letter, then we can exit from the iteration, because we know word of I and word of I plus 1 are right in the order. However, if word of I has the lexicographically larger letter, then we immediately return false. That is true, because we found one pair of words that are in the wrong order. We also need to consider the boundaries while we loop from the beginning to the end of one word. We need to check if other word has ended. Yeah, that's what I was doing. Take the words apple and app as an example. We cannot iterate over all the letters in apple because the word app is shorter. In this case, we reach the end of one word before finding the first different letter. In this case, we reach the end of one word, yeah, before the finding the first different letter. When this happens, we must examine the length of each word. If the words are the same length, or the former word is shorter, then words is sorted. However, if the latter word is shorter, then the words is not sorted. So yeah, that's what I used. So initialize hash map, yeah, ranking, So yeah, we did that. Iterate over words. Yeah, we did that. So the only place where our logic is not right is okay, they are using for loop. Word of I 0 and -1. Okay, and word of and j is equal to 0. J is less than word 1 words of I dot length. And if we don't find a mismatch letter between word, where is j? Okay, if j is greater than equal to, if we don't find a mismatch letter between words of I, and if j is greater than equal to words of I plus 1 dot length, yeah, so we return false. Else what we are doing here is that words of I character, okay, I see what's going on. So we are, so why are we doing that? So words of, oh, okay, I see what's going on. I see what's going on. Okay, if order map current word is greater than, okay, so looks like we are just reversing the first word. Yeah, first words, all the characters. And what we are checking is that, okay, if, yeah, we are always checking that if j is greater than equal to word I plus 1, yeah, so we have to return false. That is true. Then what we are doing is, if the words are not equal, then what we have to do is we have to basically get their ranking, right? We have to basically get the ranking of them, and then check if the ranking is different, right? Yeah, but the thing is, they what they are doing here is that they are incrementing the word of I dot length. Okay, word one's length, I that's what I mean. And then word 2 length is also determined by where we are traversing the current letter in word 1. Yeah, so in respect to where are our submissions, I'm not sure. Okay, yeah, in respect to this one, KUVP, suppose this is our first word, right? So we checked K and Q, then U, we checked UVP. I know UVP is smaller than Q. Oh no, but the answer should be false for this guy. uh, yeah, see, the answer is true, that it says that they are in sorted order. But in Apple app condition, the app was smaller, so A compared to this L, the first three character app matches and the second string is shorter according to the lexicographic lexicographical rules. Apple is greater than app because L greater than where is defined as blank character which is less than other characters. Yeah, that's true. So why in this case, like the KUVP case, why have they returned true for this? They should have returned false. I don't understand that. uh, have anyone discussed this KUVP thing? Okay. But at least we got the, like, not the gist of it. Like, we, I guess after starting to read the editorial, we got the idea of how to solve this question. So okay, this doesn't make sense to me at all, seriously. Like, j is equal to 0, j is always incrementing, and still if j is, see here, j is greater than, see they are always comparing j. If j is greater than equal to words I plus 1 dot length, then return false. And in this case, um, sorry, if we compare k and q, that's fine, that is that is true. But once we compare u and q, at that point our index is at 1, which means our j's length would be greater than the length of this guy, length of the second word. Yeah, looks pretty weird to me, but let's try to run what they have done there. Okay, for let I is equal to 0, I is less than word 1 dot length. Okay, and I plus plus. So if I is greater than equal to, that's what they have done, right? Solutions, oh, not editorial, that's what they have done. If it is greater than equal to word 2 dot length minus, it should be, oh, not minus 1, so they are returning false in that case. And if word 1 of I is not equal to word 2 of j, oh sorry, I, then all they are doing is comparing the, so whatever we have done here, let word 1 rank is equal to map dot get word 1 of I, and let word 2 rank is equal to map dot get word 2 of I, right? That's what they are doing here. And once we have those ranking, if word 1 rank is greater than word 2 rank, then return false. That's what they are doing here. Yep. Yeah, so if I run this, and I forgot to return true, yeah, see, there is a slight problem in this way of solving question of this question. if j is greater than length of word, then greater than equal to, see, I'm also doing that same thing. If word of ij, yeah, word of I, yeah, so word of I is not equal to word 2 of I, right? That's what they are. So the j is indicating my I over here. So word, and what they are doing is they are finding out the ranking of it. If it is greater than that, then return false. So where on earth I might be going wrong? So that's what I'm thinking. Like the hello and Leetcode should at least return true. In, let me see, word of I plus 1. I'm sending them here. Then if I is greater than equal to word 2 dot length, then I want to return false. If word 1 of I is not equal to word 2 of I, then I want to compare them. Okay, if word 1's rank is greater than, I'm not sure what's even happening with this question. Okay, let's see the JavaScript one. So yeah, this guy is doing that, and why is he, okay, anyways, 0. Okay, so he is comparing this. Okay, and how is he comparing? Yeah, he is basically getting, what is min length? Okay, minimum, yeah, minimum, he is taking the minimum length of both and then comparing. If order A order B order is equal to, then continue. Then if A order is less than B order, then -1, return -1, directly return. Okay, and return 1 if it is 1. Okay, if A dot length equal to B dot length, return 0. If it is not equal to, what the fuck is going on here? Okay, okay, just gotten the two words. Then if return false, can you at least write easy to, oh wow. So it's just that, like, whatever the minimum length is there, then we have to let min length is equal to math dot min word 1 dot length and word 2 dot length. Okay, so we've got that min length. Okay, min length. Okay, if, and we have to basically get these both guys from here. Okay, we've also got that. If and let's not consider this. Okay, so let's see if word 1 rank is greater than word 2 rank. I guess they are, it is just comparing the two words. Okay, if word a of oh, okay, okay, and if word 1 rank is less than word 2 rank, then return true. Okay, got it. I understood this question now. Else if they are just keep on going, then at the end what I have to do is b's length should be greater than or equal to return. Yep, now I understood this question. Like, I guess this question is pretty, I'm not sure if it is complicated. For me it was complicated, like it doesn't reveal what it's asking right away. But yeah, so if I just do this, should it work? It should work. Oh, sorry, I just copy pasted that word 1 and word 2. Okay, I got this one, but really complicated question. Oh, I did not submit it. Please don't reload. Oh, okay, let me write this. Had to see the editorial and also the solution specified in the solution segment to better understand this question. Must revisit this question. Okay, why is this? Okay, cool. And what I'll do is I will go to the description and see how many companies. Oh, not recently, only Facebook asked it, but not a lot of companies. Like it was a famous, like back 1 or 2 years it was a famous question, but recently companies did not ask this. So hey, thanks for sub. Okay, and recently these companies haven't been asking this question. So yeah, it is not that important, I will say. But and looking at the editorial, it did not even follow any uh, like graph data structure, because we are just comparing them right away. We are not even using any data. Even in the editorial, it's not showing any graph data structure to be used. So why this guy have introduced this in the graphs section? And that's weird. Should we watch his video? Like, why is he comparing? Okay, let's do that. I'm not sure if my internet connection would support it, but let's try to do that. Okay.
Hey everyone, welcome back, and let's write some more Leetcode today.
Okay.
So today,
Maybe. Whoops. Okay, my camera is behaving weird. Okay, now it's back. Let me. Yeah, let's see what it has to say. But before that, I just want to make sure this is working. Nope, it's not working. Let me Let me just switch my default speaker so that you guys can hear what I'm hearing. Okay, let's see.
Facebook's most
Yeah.
asked question of 2021, verifying an alien dictionary. And the funny thing is, I think this was also Facebook's most asked question of 2020, so I guess they really like to reuse questions. But let's get into the problem, and you might recognize that we've actually solved a very similar problem to this as before. We've solved the alien dictionary problem, which was actually a very hard problem, and the good news is that this problem is a lot easier, and this problem itself is actually a sub-problem of that alien dictionary problem. So if you've solved that before, you'll definitely know how to solve this. If you haven't solved that before, I think that other problem is a really good follow-up problem to this problem. And I will probably link it below if you want to take a look at the solution for that problem as well. But for this, the premise of the problem is pretty similar. So we're given alien language that happens to use all 26 lowercase English letters. But the difference is that in the alien dictionary language, these 26 English characters, A, B, C, etc., right, they could be in a different order than the A through Z order that we are all familiar with. Though the alien order could be some permutation of the ABC order. And we are given a sequence of words of the alien language that are or should be in sorted order based on that alien language. And we want to return true if these words are actually sorted based on the alien language, and we want to return false if they're not sorted based on the alien language. And we are actually given what the alien ordering happens to be. So instead of A B, C, D, all the way to Z, the alien language in this problem is actually in a different order. You can see it's H, L, A, B, etc., etc., right? So it's a different order than we are familiar with. And we're also given this list of words that should be sorted in order. Now, obviously, in real English, these two words are sorted. How do we know that hello comes before Leetcode in English order? Because we look at the first character, right? We compare character by character. These two characters are different, right? The first different characters are how we compare two words, right? Since
Oh,
these characters are
okay.
different, we want to know, okay, which one of these characters comes first? Of course, we know H is less than L in English order, right? H comes before L in the English language, right? So, of course, in real English, H, hello, is going to come before Leetcode. Is that also true in the alien language? Well, let's take a look. So we're looking for characters H and L. We can see that H is actually the first character in the alien language, and L is the second character in the alien language. So yes, even in this alien language, these two words are sorted correctly, so we return true. Of course, we can verify the alien dictionary based on the first differing character, but suppose we were given two words such as these words. We compare character by character, right? We're looking for the first differing character. So
Okay,
we look
got
at
it.
the first characters, they're both H, so they're not different. So we're gonna look for the next character that happens to actually be different. We find an E and an E, so again we shift. Now notice how one word was a prefix of the other, because we reached the end of one string, but we did not reach the end of the other string. So in this case, this word was a prefix of the other word. So then the question becomes, which one of these words is supposed to go first? Basically, it works the same way as in English. If one of the words happens to be a prefix of the other word, then the smaller word goes first. So therefore, this is a true alien dictionary, right? This is verified as true. But if it was the opposite, if we had, he come after hello, that would be wrong, right? Because we reached the end of the second string, but then there's still some characters left in the first string, so that this would basically be false, right? We can't have something like that happen. And if you kind of want to know why, it's basically, okay, we reached the end of this string, so it's basically an empty character, and here we have an L, so what is smaller? Technically, an empty character, aka a space or whatever you want to call it, is always going to be smaller than any real character. so that's why he comes before hello. So those are the only two rules that you really have to note to verify this alien dictionary. So now we can finally get into the code. Now let's get into the code. You can see that I basically summarized the two rules that we have up above. Basically, we're looking for the first differing character if we can find it. If we can't find the first differing character, that means one word is a prefix of the other. If word A is a prefix of word B, then word A must come before word B, so word B must come after word A. So the first thing we want to do is actually get the index of every single character and put it in like a hash map or something, so that's
Yep.
what I'm going to be doing. So I'm going to go through for every index character pair in our input order string. In Python, you can enumerate it to get the index and the character at the same time. We're going to use the character as a key, and we're going to use the index as the value.
How can
So
I
that's
do this thing, this exact thing in JavaScript? How to get index and character and the element in a for loop JavaScript. Okay. Oh, my arrays dot entries. If I do that, I is the index and value is okay. Can I do that here? Let's see if we can do that here instead of this traditional for loop. What I want to do is I want to get I and the character of order dot entries. If I do that, will that suffice? Or oh, and I have to also remove the ch and yeah, I plus 1. Did I get it wrong? Entries. Yeah, I wrote it right. So why is that throwing an error? Entries. I guess it doesn't support that in Leetcode. Yep, I guess so. Okay, no worries. We'll continue watching the video.
pretty much what I'm doing with this one line. So then when we do find the first differing characters, we'll be able to compare which one actually comes first in the alien dictionary. So then we just need to go through every pair of length of words minus 1, because we're going to go through character by character in the words. We're going to go in range of, and we'll verify that it was in correct order. But if we reach the end of word 2 before we reach the end of word 1, in which case this would happen, right? The J happened to be the length of word 2, but somehow we were still in bounds for word 1. That means that word 2 is a prefix of word 1, which is not allowed. So if we ever reach this condition, that means we have determined that this is not verified. We have to return false in this case. We reached the end of word 2 before we reached the end of word 1, and we didn't encounter any differing characters, and word 2 obviously comes after word 1. You can see that I plus 1. So in that case, we would have to return false. If we don't reach that case, we're going to be looking for the first differing character. So let's go character by character. If the character in word 1 is not equal to the character in word 2, then we have found our first differing character. Now we just want to know, we just want to verify that the character in word 1 comes before the character in word 2 in our order index map of word index of the character in word 1. That means we do not have a verified word list, right? Because word 2 is supposed to be greater than word 1. The character in word 2 is supposed to be greater than the character in word 1. If we have the opposite, that means that this is not verified. That means we have to return true. But at the very least, we can go ahead and break out of this for loop, meaning we can stop comparing these two words. We already found the first differing character, and it happened to be valid, so we don't have to continue. And if we end up going through every single adjacent pair of words in our words list, and we never returned false, either by finding differing characters or by finding some prefix that was out of order, then we can go ahead and once the loop is done executing, we can go ahead and return true.
So the time complexity of this, I guess, so we are running this for I loop till the end. So O of n for this, and this is the minimum length of, or let's say minimum length of word 1, right? So any of the word. So I guess n into minimum of word 1 and word 2 should be
True
the time
all the way
complexity.
outside of our for loop. And of course, I always have typos. For some reason, I took the length of words, but we actually want to take the length of words. That's what it's actually called. And then that gives us the optimal solution. As you can see, it runs pretty efficiently. Basically, the overall time complexity is the total number of words, the total number of characters in all words in the input. So I hope that this was helpful. If it was, please like and subscribe. It supports the channel.
Cool. Cool. So this guy really makes awesome videos. Like, yeah, if you're not following him, please do follow this guy. His name is Neatcode. You can search him on YouTube. But yeah, really nice. So we'll just mark it as done. But we have to revisit this question again. I'm not sure why he again added this problem to the graph list. I guess because the next question, the hard question, was part of graph. That's why he might have added that. But okay, so next I guess I'll do more problems from graph.